This is the second video for section 2.3. We are still finding domain and range, looking at equations. Don't stress too much about this stuff right now. We are going to hit it later in the chapter when we start talking about graphing techniques. So for now, just kind of think about making a t-chart or looking at the graph to find domain and range. So domain is talking about your x values. So when you think about domain, and you're thinking about a t-chart, you're asking yourself, are there any numbers that I can't plug in for x? Is there anything that won't work? For example, negative numbers. If I plug in some negative numbers in here, I'm going to have a problem. If I plug in a negative 4 into this equation, I'll have negative 4 times 2, that's negative 8, minus 1 is negative 9. And when I square root negative 9, I'm not going to get a real solution. Your calculator is going to say error, so that's a problem. I know that negative 4 is not in my domain. So I know my domain is not going to be all real numbers because I keep getting some errors when I make a t-chart. So I think it's easier to look at a graph. So if I were you, I would either use my graphing calculator or Desmos.com. Okay, let's start with domain. Domain are the x values. So you're thinking x-axis left to right. So the farthest point on the left is right here. And if you're on Desmos.com, if you've never used this, it's awesome. You just type in your equation over here and it'll graph it for you. And if you hover right above this dot right here, it'll give you the actual coordinate. So the farthest point on the left is at 0.5. And then this graph goes forever to the right, so it's going to infinity. So my domain is 0.5 to infinity. Once again, I put brackets around my 0.5 because it includes 0.5. And then you always put parentheses around infinity because you can never actually reach or include infinity. And for range, includes all of the y values. So you're thinking about the y-axis. You're going up and down on the y-axis. I want the lowest point and the highest point of this graph. So the lowest point is right here. And on the y-axis, that's 0. And then the graph is going up forever. So it's going up to infinity. So my range is 0 to infinity. Okay, let's do one more of these. We're still trying to find domain and range for this equation. If you're going to make a table, you probably want to solve for y, get y by itself. So I'm going to square root both sides. So if I make a t-chart, I'm looking at the equation y equals square root of x. I can plug in anything I want for x. I want it to be something pretty that I can actually square root. For example, 9. If I plug in a 9 into this equation, the square root of 9 is both positive 3 and negative 3. So instantly I know that it's not a function because my x does not have exactly one y. My x is going to repeat. So this thing is not a function, and you can kind of tell that at the very beginning. If your y, if the y variable has an even exponent, it's not going to be a function for this reason right here. If it's an odd function, if it's an odd exponent, yes, it's a function. But if your y has an even exponent, it's not going to be a function. They still ask me for domain and range, so I'm going to look at the graph of this thing. So I just went to Desmos again, I typed in my equation that was given to me, and now I'm going to look at domain and range. Domain is left to right, and you're going to look at the values on the x-axis. So the farthest point on the left is at 0. I'm going to put a bracket around it, and it goes forever to the right, so that's to infinity. Range is the lowest point to the highest point, and you can tell that this thing is going down forever and it's going up forever. So range is negative infinity to positive infinity. And by the way, I should have mentioned earlier that when you look at the graph of this thing, you see it's not a function because of the vertical line test. It fails it. Okay, let's move on to something a little easier. This is called function notation. You've seen this before in previous classes. Whenever you write an equation, you can either write it as y equals something, or you don't have to use y, you can use f of x. So that's saying y is a function of x. So like I said, You may write an equation like y equals 3x minus 5, or you could be more sophisticated and write f of x equals 3x minus 5. In your homework, they're going to ask you to do something like example 12. So they give you two functions. They give you an f of x, that's one equation, and they give you a g of x, that's another equation. And then they'll ask you to do different things. So in example 12, this one is asking you to find f of 2. So the f means you're going to use the f equation, and the 2 is saying you're going to replace all your x's with 2. So I took my f equation, and wherever I saw an x, I put a 2. And I actually put parentheses around it. You don't have to, but that helps me. And now you just clean it up. You can type all of this in your calculator, or you can use your brain. So 2 squared is 4, so that's going to be negative 4 plus 10 minus 3. So negative 4 plus 10 is 6. 6 minus 3 is 3. Don't do anything with the left-hand side. That's just saying you used function f and you plugged in a 2, and your answer is 3. So final answer, 3. Fun fact, that's also saying since you plugged in a 2 and got an answer of 3, it's saying you could write your answers in ordered pairs, so 2, 3. That's saying you plugged in 2 for x and got 3 for y. That's another way you could write your answer. Sometimes they'll get a little trickier and ask you to plug in letters instead of numbers. So you still have two functions. You have f of x and g of x, but this time they're asking you to find f of q. So I'm still going to use f of x, because that's what this f means, use the f function, but this time I'm plugging in q for all my x's. So all I'm doing is taking out my x's and putting in q. It's just substitution. Okay, so all I'm doing is replacing my x's with q's. I did that right here. You don't do anything to the left-hand side. There's really nothing to do on this one. You're done. That's your answer. Negative q squared plus 5q minus 3. Okay, here's another one. Same two functions, f and g, but they want you to find g of a plus 1. So pause the video and see if you can figure out what to do. So I'm taking my g function because it told me to take g, and I'm going to plug in a plus 1 wherever there used to be an x. So I'm going to take out that x, and I'm going to put in a plus 1. And now I'm just going to clean it up a little bit. So I distributed my 2 combined like terms. Final answer should be 2a plus 5. Okay, look at this one. This one's a little different. This time they give you a set for f, and they want you to find f of 3. That's saying when x is 3, what is y? So you're looking at each one of these as a point, x and y. So when x is 3, that would be this point right here. When x is 3, what's y? 1. 1 is your answer. Same kind of thing, except they give you a mapping diagram, but they're still asking you to find f of 3. So f of x, when x is 3, what is y? So when x is 3, what is y? It's 5, so your answer is 5. Even if they give you a graph, it's the same kind of thing. So they're giving you a graph and they're asking you to look at it and find f of 3. So that 3 represents x. When x is 3, what's y? So I go over to 3 on the x-axis and I go up until I hit that graph. That point right there is 3, 4. So when x is 3, what's y? Y is 4. Okay, they're also going to ask you to look at these funky little graphs and decide where the graph is increasing, decreasing, or constant. So you read a graph like you read a book left to right. So this first part of the graph is really decreasing. Even I know that arrow is pointing up, but don't look at that. You read it left to right like you read a book. So I'm going down, so that's decreasing first. And then this part is increasing, and then this part is constant. So let's just look at this first part right here. That is decreasing because left to right, that's going down. And when you use numbers in the intervals for increasing, decreasing, and constant, you only use the ones on the x-axis. So this part right here, since we only use numbers on the x-axis and the x-axis goes left and right, I'm just doing this first part right here. It goes forever to the left because this arrow is going forever to the left, so that's negative infinity. And then the farthest point on the right is right here at 1. And I'm going to use a parentheses around that 1 because it's an open circle, so it's actually not including 1. Then if I go to this next piece right here, it's increasing, and I'm using the numbers on the x-axis, so it's from 1 to 3. And I'm going to use brackets around 1 and 3 because I have a closed circle here at 1 and a closed circle here at 3. And then this next section right here, it's constant, and I'm using numbers on the x-axis, so it's going to go from 3, that's the farthest point on the left of that section, and it goes all the way to the right to infinity. So I use a bracket around 3 because it's including 3, but parentheses around infinity because it will not include infinity. Okay, last one, and I promise I'll leave you alone. Look at this graph and see if you can write the intervals for where it's increasing, decreasing, and constant. Okay, so if I look at the part that is increasing, that's from here to here. So if I use the numbers on the x-axis, that's 0 to 25. So I would write it like this. That's the interval for which that graph is increasing. And I guess it didn't ask for the interval, that was just extra. The real question is how long is the water level increasing? So from 0 to 25, the answer would be 25 hours. If you wanted to write the interval for which the graph is decreasing, it would be this little chunk right here. So you're going down to the x-axis, so it would be 50 to 75. And then if you want to know how long the water level is decreasing from 50 hours to 75 hours, that would be 25 hours. And then constant would be these two parts right here. It'd be right here and right here. So that would be 25 to 50 and 75 to 100. So right here is 25 hours, right here is 25 hours. So it's the water level is constant for a total of 50 hours. All right, finally, we're done with 2.3. I know that was a lot, but try your homework and we'll do some more examples of these in class.